there's so many different things to think about in order for something to be sustainable, for something, like, is it better for the environment? Is it better for the economy? Like, it's that trade-off that's really quite difficult to navigate sometimes. And the reason that embodied carbon is on the screen is because, particularly in sort of the big railway infrastructure projects that we see on the railway, such as large bridges, tunnels, etc., you get a really huge amount of embodied carbon. And yeah, just wanted to reiterate that the actual term carbon here is actually referring to a number of different things. So it's sort of referring to like greenhouse gases that are released, and it's not just carbon, it's like all of the other greenhouse gases as well. So that's just a point to note that's quite important.
Yeah, because you have it's measured in equivalent CO2
exactly.
tons, right? So it's not just CO2, but it's methane, it's sort of some of the other sulfide gases, all the various gases that contribute an equivalent amount to CO2 in terms of greenhouse gas effect.
Exactly, yeah. And so it's really important to just note that it's not just talking about carbon, it's talking about a lot of number of different things. And basically, you'll often see it written in terms of CO2e. So yeah, like you said, this carbon dioxide equivalent, and that just enables different greenhouse gases to be expressed as a single value to allow for a comparison. And so, embodied carbon is extremely important because some of the key materials that we work with are some of the key contributors towards global warming and greenhouse gas emissions. So, for example, concrete, steel, all of the fill that we use, and there is lots of key hotspot elements. And so, what really sort of struck me was like I was reading, I think it was like a copy of the NCE a few months ago, and I saw someone's quote that I thought was that really stood out. So they're saying that, civil engineers and a lot of a number of the other engineers also sort of were part of the problem in the past. And, now we have to be part of the solution. And I think that that's a really good way of looking at it. And I think that embodied carbon is becoming more and more relevant and more important in the world that we work in, and also the world that we live in. And so, yeah, you can tell me if I'm talking too much, Gareth.
No, that's perfect. It's really good. I've done too much talking already, so it's good. No, so we've got a few questions coming through. I don't know if you wanted to take a couple of questions and then we can keep.
Yeah.
Is that right? So we've got a really good question from David Shepherd that I'm going to ask now, so I don't forget. And it might be one that in fact, hopefully one that I think you might have an answer for it. Which is if the railways can use construction materials or construction approaches that actually lock up carbon, so they can actually be carbon like carbon positive, like negative, whichever way around it would be, but essentially store and capture carbon in there. Are there any materials we can use, any approaches we can do that in that sense?
I would have to look more into that, because sort of more typically on the infrastructure projects that would be for railways, it would be, like large bridge structures or tunnels. And so, for actual structural materials, your main two things that you'd go to automatically are concrete or steel. And so maybe for any sort of additional ancillary works or something like that, but for main elements, I can't see of any direct things to swap that for.
Because ultimately we need the structural properties of those two materials. So where it's structural, you kind of need those, right?
Yeah, and so, but there is definitely a lot of like research and things going on. So one thing that leads nicely into is that, concrete has like such a large footprint because of the carbon emitting process that is used to make the Portland cement. And so, one of the key things that can be done when you're sort of specifying or designing a structure is to look at, the strength type of the concrete that you're specifying. Does it really need to be C50-60, or can you design it to be something less? And really focusing on like the mix of the concrete, because there are lots of different ways that you can try and amend the mix and try and replace certain things. So, for example, you can replace some cement with other supplemental cementitious materials, such as fly ash or blast furnace slag. And there's lots of different ways that you can try and look at this. And one really interesting thing to note was that at the Mexico City airport project, so Arup actually conducted like a really large life cycle assessment study to try and reduce embodied carbon. And they spent a lot of time looking at this, and they actually, the biggest thing that had the biggest effect was actually that looking at the concrete mixes and also the like efficiency of the structural steel work, so trying to reduce any excess material of the steel work.
Interesting. Yeah.
So yeah, so the concrete mix and the amount of steel, which I think is really interesting. But yeah, so yeah, concrete and steel are like your biggest hotspots and your biggest players here. And so it's about like understanding your design, not necessarily picking up standard designs, which I know is sort of pushed on us a lot in the railway industry. And yeah, it's sort of challenging that, thinking about, are there any ways that I can, change the grade of concrete, change a specification of concrete? Do I really need this I section to be this thickness, etc.? It's about, trying to think in that way and having those questions.
And is that I suppose if I flick back a slide actually, so these two slides, one of them is the demolition works near Euston, I think, for High Speed 2. I've tactically used a load of High Speed 2 pictures because well they're public domain, so that helps for this. And the other one there is a recently released picture actually of the southern portal just next to the M25 of the Chiltern Tunnel. So this is going to be a 16-kilometre long tunnel under the Chilterns, which will release a huge amount of carbon. There's no avoiding the fact that represents a big old chunk of carbon. But some of the interesting things you can do is, often good engineering practice does lend itself to reducing the overall carbon footprint. So you talked about reducing, for example, reducing the thickness of an I-beam, or using less, reducing your cube strength for your concretes. These are things that reduce costs. They reduce complexity. For example, with an I-beam, if it means it's lighter, then you maybe need a smaller crane to move it around, for example. So and reducing construction timescales can help. You've got less mobilised for less. So it's all these, but it's a huge complex mix, and it's almost like it would almost benefit. It's one of those things a bit like data, when you think, actually, would it be worth there being a design discipline that actually inputs into all these things? That I've always wondered that, like, because there is so complicated. You could almost study it as its own discipline, right?
Yeah.
So we'd all generally have a bit of an understanding, but then you'd have a person sat in an interdisciplinary kind of meeting, going, right, well, I've done my design, and you need to check this, and reduce this. Yeah. Anyway, so I put these pictures up, and then I put this one up of the viaduct. This is just south. This is over the Colne Valley. The Colne Viaduct, which is just south of that portal, actually. So that construction site is where not only they're building the tunnel, but they're also going to build this bridge from there, which looks awesome. It does look awesome, but that also looks like it's going to have a lot of concrete in it. So I suppose hollow, the less concrete in cross section is good, right? So if you've got more hollow sections and
and also like try and reuse materials as much as possible on site, and all of this stuff. I think there's such a broad range of things that you can try and think about, and I think especially sort of on these large scale projects, I think the key limitations are that you're required to use that structural strength of the materials, so there is like a limit that you have to go to. And I also think that there's a lot more guidance to do with buildings, so you have like the Green Building Council, you have like all of these like bodies that have a lot of specifications, a lot of documents,
quite heavily regulated.
And it's a lot easier to sort of find that information and look at good case studies and have examples. So I think in particularly like railway infrastructure, bridges, tunnels, etc., I still think that it's a little bit behind in comparison to the buildings.
Yeah, so more to be done then. A lot more to be done.
Definitely, yeah.
We've
definitely.
Owen O'Neill is asking whether, I think this is a question you might answer later actually, which is whether road and rail schemes do their CO2 maths, their carbon maths in the same way, or are we shouting at ourselves a bit more perhaps than the road schemes are, or is it vice versa? Do we not do enough in rail compared to road? You're allowed to wait until the slide on calculators if you want to answer it later.
Sure, I'll wait. I'll answer that one a little bit later. Yeah.
So Julia was in York when you started, right? Other way around. Julia started when you were still in York. Yeah.
Yeah.
So Julia is a cement. She did a doctorate in cement, right? And so she gave I find it fascinating. Other people around were like starting to get a bit confused by all the chemical equations, but I found it really fascinating. And she was studying the really going into the chemistry of cement.
Exactly,
to reduce to keep structural properties whilst reducing the requirement for the carbon intensity. Oh, it's fascinating, really interesting. a rail natter on cement perhaps is.
Yeah,
So,
you should
yeah.
get Julia on
Yeah,
next
yeah,
for
that's
sure.
it, yeah.
For sure.
Yeah. So we talked about embodied carbon,
Yeah.
and so just to clarify, so the embodied carbon is so the construction process, but in terms of do we count construction process carbon as the carbon that is released by concrete through its whole life? Because it's not like carbon stops giving out CO. It actually still gives out CO2 through its life, doesn't it? By the way that it sets. It's not the right word. I was hunting for the right word, but yeah.
So
Cures, that's the one.
yeah, so for example, anything to do with like transportation, the actual materials, etc., would all be, how it's built on site, all of these things. So again, it's much more clearer in terms of for a building because you'd have all of that work done at the start, and then your operation would be more things to do with the lighting of the building, the outputs for the heating, the cooling, etc. And so that's why when you start looking more into embodied carbon and operational carbon, it's really important to sort of define the boundary conditions that you do the assessments for. Yeah. And so,
So
sorry.
no, go on.
Yeah. So like I was saying, it's much more clear cut in terms of buildings, so you have everything that's the physical aspect of all that's put into the structure, all that's put into the building, all the like physical work, the labor, etc. And then throughout the operational phase is just how it's maintaining, how it's being run, etc.
Yeah, so I then stuck this. We've got a couple of pictures here of kind of operational things that represent operational carbon. So running the trains, I'm guessing that would fall under the category of operational carbon. The actual juice that they suck out of the overheads. That's operational carbon, right? Maintaining them, I suppose, maintaining the trains. So the electricity that's being consumed at the depot, that's operational carbon, right?
I would think so. Again, it's quite like it's probably quite subjective because you'd have to look into. So, for example, when you're designing something, for example, you might say, I'm designing a structure for a 120-year design life, and you've maybe got steel versus GRP, and the GRP has a higher embodied carbon, but will need replacing less, and then you've got your steel that has a lower embodied carbon but needs replacing more, and then I think that's where it gets a bit.
Yeah, so just like costs, which increasingly our industry is looking at the whole life of the assets we're upgrading or installing. It's the same with carbon, right? We need to look at that whole life. So on the existing railway, obviously we don't really look at the trains because that's, well, firstly it's run by we've fragmented our industry, but also we're not really in the business of worrying about the trains that run over it, and also it's a very complicated mix. Whereas for high speed 2, it's easy for them because the trains they're procuring are being procured just for HS2. So the depot and all the stuff is just for HS2. So that they are looking at the whole. They're looking at trains. They're looking at everything. And so the other picture I've got here is a Birmingham interchange station. Now this is the first station. This is a carbon neutral station, so it'll be a zero carbon station, which is cool. So it generates enough electricity. It generates the same amount of electricity that it'll use up. It has loads of energy saving features like automatic wind cooling, fancy stuff, and all sorts of good bits and pieces. I think it's got the highest BREEAM. It's BREEAM outstanding. So in terms of building ratings, we were talking about earlier, BREEAM is one of them, right? And this is the only station in the world that's got or will have, or has already got for its design, outstanding rating according to BREEAM. Which BREEAM's not a watertight assessment system, but it's not bad going. It's not a bad precedent to set. So, which kind of answers another question we've had: is can stations be carbon neutral, or how much carbon can railway stations with solar panels earn back? Well, they can make themselves carbon neutral, which isn't too bad. So so this is operational carbon.
And just one thing I wanted to say is that I don't actually think I answered your question, Gareth. So all I wanted to say was that how you said concrete still emits. Will still have things to do with its decommissioning, with its like end of life use, etc. That is still part of embodied carbon, because operational is sort of like I was trying to explain that lights, all of this extra stuff, like how it needs to be powered, like all of these things, it's cooling, etc. Whereas the actual embodied carbon still takes into account like the extraction, manufacture, transportation, assembly, maintenance, like replacement, deconstruction. and disposal. But again, it depends on the boundary conditions. So it depends on what type of embodied carbon analysis you're carrying out, whether it's a cradle to site or whether it's a cradle to grave.
Interesting.